All right, page 2 of the 2.3 notes. Example 3, we want to graph this function and then graph this function on the same axis and then see, where do they intersect. So if we're going to graph our first function, 3 times the absolute value of x minus 2 minus 1. So let's see, our vertex is shifted right 2 and down 1. So we're going to go over 2, down 1. There's my vertex. My a value is 3, so I'm going to go up 3 over 1. Up 3 over 1 the other direction, and I can do more points if we want to, but that's enough. We can draw our v. It's going to look something like this. Okay, so there's f of x, and then g of x is the line y equals -5, so we're going to go down 5, and then draw a horizontal line. Okay, so then there's g of x, and then we want to highlight the portion of f of x where f of x is greater than g of x. Okay, so again, let's interpret this. Let's see, f of x is my v, g of x is my line, and then greater than basically means above. So then we want to highlight the portion of our function where our v is above our line. So then on our graph here, where is the v above the line? Well, this entire thing is above that line, right? Okay, so then that means, what values of x work? All of them. Okay, so then the algebra solution is what? Well, everything works, so then it should be all reals. Okay, now why is that the case? Let's take a look at our equation. If we look at our equation, which basically is right here, f of x is greater than or equal to g of x. Well, that's going to be, and we're going to squeeze it up at the top here, 3 times the absolute value of x minus 2 minus 1 greater than or equal to g of x, which is -5. Okay, so when does that, scoot this down a little bit, when does that equation come out true for what values of x? Well, let's see, if we're going to solve an absolute value equation, we always want the absolute value part by itself. So let's start by adding 1 to both sides. I'm trying to write small here. We get 3 times the absolute value of x minus 2 is greater than or equal to -4. And then when I divide both sides by 3, we get the absolute value of x minus 2 is greater than or equal to -4/3, and just leave it as a fraction. That's fine. Okay. Now, ignore the part in the middle. It doesn't matter if it's x minus 2 or something else, but the absolute value of what is greater than or equal to -4/3? Well, since it's negative there, no matter what goes in here, the absolute value bars are going to make it positive. So then when is a positive number greater than or equal to a negative number? Well, always. It's always going to be greater than. So then the algebra solution is all reals. And we can write that in a shorter way by putting an R with 2 vertical bars there. Okay, so this symbol means all reals. If we wanted to write that in interval notation, so we can say, or we could write it like this. Anything from -infinity to +infinity is going to work. Okay, so it doesn't matter what we plug in for x, this equation is always going to come out true. Okay, now part B says how would the answer have changed if we were to graph the function f of x is less than or equal to g of x. Okay, so in other words, what if we flip this sign around? Okay, then how would that work? When is the absolute value of something less than a negative number? Well, never. So then if it was flipped around, then it would be no solution. Okay, and we don't need to do the work again. All that would happen is we would flip this sign around. And again, since this is always going to come out positive, well, when is a positive number less than a negative number? Never. So if the sign was flipped around, we'd have no solution. So you're going to get some problems where your answer is going to be either all reals or no solution. But the thing you want to watch out for, if I have a problem like this, it's a greater than problem. Can I set up my 2 equations and solve and get some answers? Sure, but they'd be bogus. But if this is flipped around, could I make my less than sandwich and solve that big compound inequality? Well, sure, but again, my answers would be bogus. So once you get the absolute value part by itself, you need to always check and make sure, do we have a negative? Whether it's an equal sign or an inequality, look for that negative here once the absolute value part is by itself. Okay, because again, sometimes we'll get all real numbers or no solution. All right, moving on, and now we're just going to solve algebraically and then also write our answer on a number line. So the next one, Solve using algebra steps and graph the solutions on a number line. So here, again, we want to get the absolute value part by itself first. So let's start by subtracting 3 from both sides. And then that gives us the absolute value of x over 4 plus 5 is less than or equal to 6. I think we can zoom in on this a little bit now since we're not graphing. Okay. All right, and then again, ignore the stuff in here. The absolute value of what number is less than 6? Well, since it's less than and not equal to, we don't want to do it that way, actually. Since it's a less than problem here, we want to set up our less than sandwich. Okay, so again, to make the sandwich, this stuff in here goes in the middle. So I got x over 4 plus 5 in the middle. Both my signs are facing that way. So I'm going to put one here and one here. And then I got the positive answer on the right, the negative answer on the left. Okay, so now we've created our compound inequality, in other words, our less than sandwich, and now we can solve. So when you solve, focus on the middle. How do I get x by itself? Well, what am I doing to x here? I'm dividing by 4 and then adding 5. So I'm going to do the opposite of that stuff in the opposite order. So we'll start with subtracting 5 from all 3 parts, which is going to give me negative 11 less than x over 4 less than 1. Okay? And then now in the middle, I'm taking x and dividing by 4, so then I want to do the opposite of that and multiply by 4. So I'm going to multiply all these parts by 4. And that gives me negative 44. It's less than, it's not a very good less than symbol, it's okay, x less than 4. Okay? And then those are my answers. Okay, and then how do we graph that on a number line? Well, here's my number line. And really the only 2 points I need on there are negative 44 and positive 4. Now be careful because it's not less than or equal to, greater than or equal to. It's just less than and greater than. So we could have open circles at negative 44 and an open circle at positive 4. Okay? And then I want everything less than 4, so that's going to be all the points going this way. And everything greater than negative 44, so that's going to be everything going this way. So again, our answers are sandwiched in between those 2 numbers. Okay, so again, we get that less than sandwich. If you want to put 0 somewhere kind of close to the 4, that's fine, but that's optional. Okay, next one. So the algebra is going to get a little bit trickier, but the idea stays the same. So here again, we want to get the absolute value part by itself. So let's start by adding 2 to both sides, which gives me 3 times the absolute value of 2x minus 6 is greater than or equal to 30. And then divide both sides by 3. Something you also want to keep an eye out for. Remember, if you multiply or divide by a negative, you have to flip the sign. Okay, but this is a positive 3, so we leave that alone. And we get the absolute value of 2x minus 6 is greater than or equal to 10. Okay? And then since this is a greater than problem, we're going to set up our 2 cases, in other words, our 2 equations. And we're going to do that up here. Okay, so one of my equations looks just like this without the absolute value bars. So we get 2x minus 6 is greater than 10, sorry, greater than or equal to 10. I want to see when that happens. And then we also want to know when this stuff is less than or equal to the opposite of that answer. In other words, when we set up our second equation, I want to do 2 things. I want to flip the sign and make my answer negative. So my second equation, we're going to scoot it over here, is going to be 2x minus 6 is less than or equal to negative 10. And those are going to give me my 2 sets of answers. Okay? All right, so let's solve these. To get x by itself, I want to start by adding 6 to both sides of my equation. And I'm going to do these at the same time since the left side of the equation is the same in both of them. And I get 2x is greater than or equal to 10. I'm sorry, 2x16. And 2x is less than or equal to negative 4. Okay, and then last step, in both equations, we want to divide both sides by 2. Okay, and then we get x is greater than or equal to 8, and x is less than or equal to negative 2. Okay, so then those are my 2 answers. Okay, my 2 sets of answers, I should say. All right, and then the last thing we want to do is graph this on a number line. Let me zoom out a little bit so I don't hide too much from you. We're going to just squeeze it in over here on the right where I got a little bit of space. So again, the 2 points I have to have on there are -2 and +8. Since it's less than or equal to, I can fill in the circle at -2 here on the left. Greater than or equal to, I can fill in that circle at +8. And then where are the numbers less than -2? Well, that's going to go to the left. And then where are my numbers greater than +8? Well, that's to the right of +8. So again, a less than problem, your answer should be sandwiched in between the two numbers. A greater than problem, they should be going away from each other. Okay? They should never be going the same direction. If they did, you made a mistake somewhere. Okay? All right, one more on this page. Here we got negative. You can think of this as -1 times the absolute value of 7x minus 2 is less than or equal to 19. Okay, so let's start by getting the absolute value part by itself. I can either divide by -1 or multiply by -1. Doesn't matter, it achieves the same goal. I'll go ahead and multiply. And then that gives me, here the negatives cancel, so I just get the absolute value of 7x minus 2. And then don't forget, since we multiplied by a negative, I need to flip that sign around, make that greater than or equal to now. -19. Okay, so it's a greater than problem, so then should we set up our two cases? No, why not? Well, ignore this stuff, that doesn't matter right now. The absolute value of what number is greater than or equal to -19? Well, anything will work, right? It doesn't matter what I plug in for x, because after I multiply by 7, subtract 2, and then make it positive, well, no matter what positive number it is, it's going to be greater than -19. What's the smallest thing this could come out? 0, right? The smallest thing in absolute value problem can come out as 0. So then, yeah, it's always going to be bigger than -19. So then what's my answer here? Well, all real numbers. Okay? In other words, from negative infinity to positive infinity, I can plug in anything I want for x. All right. Now, just so you know, we are skipping a whole page of extra examples because I don't want the notes video to be too long. And we're going to go to the last page, which is the only one I made available for you guys. Okay? All right. So at the top here, starting off with another example, absolute value of 2x minus 4 is less than or equal to 10. Okay? All right, so this one, we just want to set this thing up. So how do we set up this problem? Okay, well, it's a less than problem, so then I want to make a less than sandwich. So then this stuff goes in the middle, 2x minus 4. My signs are both going to be facing the same way. They're always technically less than, just depends on which way you're reading it, though. Sometimes you might say greater than. Okay, I can say this stuff is greater than that number. And then anyways, the positive answer goes on the right. The negative answer goes on the left. Okay, so then that's how we would set up our sandwich. Now, what's another way of writing the solution other than in a sandwich? Well, if I ignore this part of my equation over here, well, what do we have right here? Well, we have 2x minus 4 is less than or equal to 10. Okay, got that one. And then what else do we have if we ignore this part of the equation? Well, in here we've got 2x minus 4 is greater than or equal to -10, if we're reading that backwards from right to left. So 2x minus 4 is greater than or equal to -10. Okay? So we can write a less than problem using the two equations. If you don't like the big compound equation or compound inequality, you can split it up and write it as two separate equations. Similarly, if you would like to, when you get a greater than problem, you can make a compound inequality out of that as well, kind of just by putting it together. The key, the reason you can do that is because these two parts are the same. Okay? So like it says down here, one rule we can think of, when we solve an absolute value less than problem in sandwich form, it's the same as using the word and. Okay? Because this equation is the same as this equation and this equation combined. Okay, so we can even put, and in the middle. Okay, so this is the same as this and this. Okay, so really what it comes down to is preference. If you like setting up two equations, you can do every problem like that. If you like setting up the compound inequality, you can do every problem like that too. Okay, if you guys have questions about that, just ask me in class. Oh, I'm sorry, I think you'll cut out the word and. So and is what goes in the blank. Okay. All right, one last problem to do, and then we are done with these notes. Okay, I know it's a little smaller. Hopefully you can read it. If not, look at your paper instead of the screen. So application problem says the manager of a beachside hotel recommends that the hotel has on hand at any time enough beach towels per the formula. Well, they should have, the towels should equal 4/3 the number of guests. In other words, they should have 1/3 extra towels for all the guests. If the hotel has between 80 and 240 towels, how many guests is the manager expecting to be on the beach? So we want to write a compound inequality in terms of G, the number of guests. So we're writing it with G instead of X is the main thing. Okay. All right. So what's our compound inequality going to look like? Okay. Well, how many guests do we have? We have 4/3 the guests as we do towels. So we want 4/3 G in there because again, we have 4/3 the number of guests. And then, well, 4/3 the guests. How are we going to write that in a compound inequality? Well, it's got to be less than or equal to some number and then greater than or equal to some number. And then obviously it's got to be greater than the smaller number of towels that they have. So less than 80. Sorry, greater than or equal to 80. And then at the most, it's got to be less than or equal to 240. Okay? So basically, it's going to be the fraction times your variable, and then these are going to be your small number and your big number. Okay? All right, then once you have the compound inequality set up, then we want to solve that equation. So then how do we solve the equation? Let's rewrite it so we can actually show our work down here. Okay, so we had our equation. We know that the number of guests is going to be 4/3 times G. So just writing it again. Okay, and then how do we solve this thing? Okay, well, we want to get G by itself. So our only step to do that is to multiply both sides by the reciprocal of 4/3, which is 3/4. So I want to multiply everything by 3/4. Okay, and then that gives me 3/4 of 80. Again, this just means multiply by 3 and then divide by 4, or divide by 4 and multiply by 3. But we get 60 less than or equal to G, less than or equal to, let's see, that'd be 180. Okay, so then how many guests are they expecting at the hotel? Well, between 60 and 180. Okay, so yeah, it varies, but that's why the number of towels varies. Okay, all right, and then that is the 2.3 notes.